Electrical fundamentals. In modern vehicles, electrical systems play a vital role in almost every function, from starting the engine to powering lights, entertainment systems, and advanced safety features. Understanding the basic principles of electrical circuits, fuses, wiring, power distribution, and battery systems is essential for diagnosing and repairing electrical issues in vehicles. This lesson will provide foundational knowledge of these core elements of automotive electrical systems, laying the groundwork for more advanced topics in electrical diagnostics and repair. An electrical circuit is a pathway through which electricity flows to power various vehicle systems. Understanding how these circuits function is fundamental for diagnosing electrical issues. Basic concepts. Voltage. Voltage, or electrical potential difference, is the force that pushes electric current through a circuit. It is measured in volts. Example: the electrical system in a vehicle operates typically on a 12-volt DC system. Current. Current is the flow of electric charge through the circuit, measured in amperes. It represents the quantity of electricity flowing. Example: a car's starter motor may draw a high current when engaged to start the engine. Resistance. Resistance is the opposition to the flow of current in the circuit, measured in ohms. Higher resistance means less current flow for a given voltage. Example: the resistance of wires and electrical components impacts how much current flows in the circuit. Power. Power is the rate at which electrical energy is used or produced, measured in watts. The formula for electrical power is P equals V times I. Example: an electrical motor might require a certain amount of power to operate, calculated by multiplying the voltage supplied by the current it draws. Ohm's law. Ohm's law is fundamental in understanding how electrical circuits work. It states the relationship between voltage, current, and resistance in a circuit. V equals I times R, where V is voltage, I is current, and R is resistance. By using this formula, you can calculate one of the three variables if you know the other two. Series and parallel circuits. Series circuits. In a series circuit, components are connected end to end, and the current flows through each component. The total resistance is the sum of the individual resistances. Example: the lights in a simple circuit may be wired in series, so if one light goes out, the rest will go out too. Parallel circuits. In a parallel circuit, components are connected across common points, and the current divides between the components. The total resistance is less than the smallest individual resistance. Example: car batteries and electrical components are usually connected in parallel to ensure that if one component fails, others continue to work. Fuses and circuit protection. Fuses are safety devices used to protect electrical circuits from overloads or short circuits. They are designed to blow or melt when the current exceeds a safe limit, preventing further damage to the circuit. Function of fuses. Fuses are essential for preventing overcurrent conditions, which can lead to overheating, fires, or damage to electrical components. How fuses work. Fuses consist of a thin metal wire or filament that melts when the current flowing through it exceeds the rated capacity. When the fuse blows, the circuit is disconnected, preventing further electrical flow. Types of fuses. Blade fuses. These are the most common fuses in automotive electrical systems. They come in various amperage ratings and are used for a wide range of electrical components. Glass tube fuses. These fuses are often found in older vehicles and are typically used in low-current applications. Resettable fuses. These fuses can reset themselves after an overload is cleared, allowing for continued protection without needing to replace the fuse. Fuse ratings. Fuses are rated by their amperage, which corresponds to the amount of current they are designed to carry before blowing. Example: a 15-amp fuse will allow 15 amperes of current to flow through it before it blows. Correct fuse sizing. Always replace a blown fuse with one that has the same amperage rating to prevent overheating and damage to the circuit. Wiring and power distribution. Wiring connects various components of the electrical system and carries the current from one part to another. Proper wiring is essential to ensure safety and prevent system failures. Wiring components. Wires. Wires are the main conductors in a vehicle's electrical system. They come in different gauges depending on the current they are designed to carry. Connectors. Electrical connectors are used to join different parts of the wiring system, ensuring proper electrical contact. Grounding. Proper grounding is essential for safety, as it provides a path for electrical currents to return to the battery and helps prevent electrical shocks. Power distribution. Power is distributed from the battery to various electrical components throughout the vehicle, including lights, sensors, and the engine control module. Proper power distribution ensures that all components receive the appropriate amount of current. Power distribution panel. Modern vehicles have a power distribution panel that controls the flow of electrical power to different circuits. Alternator. The alternator charges the battery and powers the electrical systems while the engine is running. Battery systems. The battery system stores electrical energy and supplies it to the vehicle when the engine is not running. It also stabilizes the voltage and provides current to start the engine. Primary function. The battery stores energy as chemical energy and converts it to electrical energy when needed to start the engine or power electrical systems when the engine is off. Components. Battery cells. A typical car battery has 6 cells, each providing about 2.1 volts, giving a total voltage of around 12.6 volts. Terminals. The battery has positive and negative terminals where cables are connected to the vehicle's electrical system. Electrolyte. A mixture of water and sulfuric acid that facilitates the chemical reaction necessary to produce electrical energy. Battery charging and maintenance. Charging system. The alternator charges the battery while the engine is running. If the alternator fails, the battery will be drained and electrical components will stop working. Battery testing. To ensure the battery is working properly, perform regular voltage tests using a multimeter. A fully charged battery should show around 12.6 to 12.8 volts with the engine off. Summary of electrical system components. Here's a table showing the summary of the different electrical system components, including their function and common problems. You can pause the video if you want more time to review the table. Conclusion and recap. In this lesson, we explored the fundamentals of electrical systems, including hydraulic braking systems, fuses, wiring, power distribution, and battery systems. A solid understanding of these core components is essential for diagnosing, maintaining, and repairing electrical systems in vehicles, and it's critical for preparing for the ASE certification test A6.